Hi, this video looks at critical path analysis as a topic to revise for A-level business, for your A-level business exam. This is what a critical path analysis looks like, and what it represents is an activity or a project that a business could do. It might be a construction project, building a new building. It could be a website design. It could be doing a marketing campaign. This is actually an old example from an AQA paper of a project that was to start a car sharing company. Okay, one of those Zipcar like deals where they have thousands of cars and you become a member of Zipcar and then you can go and you know basically borrow a car for a day. Right, that relies on them having lots of cars parked around the city. Zipcar now operate in London, they might operate in other cities too. Anyway, the business requires to get off the ground tasks to be done. And we can see here the tasks that they've laid out. Okay, task A, conduct market research. Task B, obtaining the parking base. Task C, staff recruitment. The tasks in the diagram down here are represented by the lines. Okay, task A, conducting market research, they estimate will take 2 weeks. Okay, the duration for each activity is in weeks. The duration is the number below the line. Remember, the line represents the activity. These nodes here represent the start and the end of the activity. Okay, so activity A, 2 weeks, activity B, 10 weeks, activity C, 6 weeks. Activities A, B, and C can be done at the same time. That's what this represents. We can get activity A, B, and C done at the same time. Okay, activity D, on the other hand, which is implementing the marketing plan, relies on task A, conducting market research, to be done first. You can't do task D until task A is complete. Task G down here, test marketing, relies on activities D, E, and F having been completed first. Okay, so that's what these three lines going into this node here represents. We can't start activity G until we've done all of the other activities. Okay, so what you might get in an exam is something like this, where you've got certainly one node covered, or I've got a couple here so we can work it out. Okay, so the first thing to do when conducting a critical path analysis is to calculate the earliest start time. The earliest start time is this number in the top right-hand corner of the node here. It basically says what's the earliest time that the activity that follows it to the right can start. So if we have a look at activity J here, we look to the left of the line. The earliest start time for activity J is week 18. Okay, the earliest start time for activity H is week 6. So first thing to do, if you've got any gaps, is to work out what the earliest start time is. Okay, so activity D, the earliest start time for it is 2. How do I know? Because it has to wait until A is completed. So 0 plus 2 is 2, right? Let's have a look at activity G. Remember, activity G needs D, E, and F to complete. So 2 plus 4 is 6, okay? That's when activity A and D can finish. B and E take 15 weeks, 10 plus 5. Activity C and F, which also need to complete it, 6 plus 3 is 9. Okay, so the longest of those is B and E at 15 weeks. Activity G needs all of these things to be done, so 15 goes in there. Okay, and I've got this one covered up as well, so we can just practice. Activity C takes 6 weeks, so activities F and H, which need C to be completed, can start at 6 weeks. All right. Activity I needs H to be completed as well. 6 plus 5 is 11. So we're going to have 11 in there when we reveal it in a minute. All right, what about the number in the bottom right? So what you do is you work all the way across and you complete the earliest start times. Okay, the latest finish time says what's the latest that this activity can be completed without delaying the project overall. All right, so let's have a look at activity C here. It's got a latest finish time of 12. Okay, well, why does activity C have a latest finish time of 12? Okay, it means that activity C has to be completed by week 12 or else it will delay the project overall. Okay, so the activity is due to finish, the whole project is due to finish at week 23. Okay, 12 plus 5 is 17. 17 plus 1 is 18. 18 plus 5 is 23. Right, let's just say this finishes in week 13. Okay, it doesn't meet its week 12 deadline. Well, 13 plus 5 is 18. 18 plus 1 is 19. All right, that means we can't start activity J until week 19, which takes 5 weeks. That pushes it up to 24. Right, so when we're working backwards, how do we fill in the bottom right-hand number, the latest finish time? We simply subtract. 18 minus 3 is, is 15. Okay, let's have a look at the completed version. Let me just get rid of these. Okay, sorry about that. So now we can see 18 minus 1 is 17. 17 minus 5 is 17 minus 5? Yeah, it's 12. 15 minus 3 is 12 as well. If there's a situation like this, you go with the lowest number in here. Okay, the lowest number goes in here. 15 minus 4 is 11. So this one, you have to, if there was a difference, you go with the lowest number in there. So that's the latest finish time. Okay, one more thing that we might need to calculate is called the float time. Okay, so the float time is, right, the critical path is the path along which there cannot be any delays, right? And we know the critical path in this case is B, E, G, J. Right, we can't have any delays along there. How do I know? Because if any of these activities are delayed, then it's going to affect the project overall. Okay, so say activity E takes longer than expected. It takes 6 weeks. That's going to push 10 plus 6 is 16, plus 3 will be 19, plus 5, 24. We've extended the project, right? So none of these activities with the same numbers in can be delayed, or else you're going to delay the project overall. So any activity where these numbers are not the same is going to be float time. All right. So how do I calculate float time? It's latest finish time minus duration minus earliest start time. So just to be clear, the latest finish time for activity G is over here in this box. So the earliest start time for G is up here. All right. So for H, earliest start time is week 6. The duration is 5 weeks. The latest finish time for activity H, I'm looking to the right at the bottom, latest finish time is 17. Right, so I know that my float time for activity H is going to be 17 minus 5 minus 6. And hopefully we'll be able to calculate we've got 6 weeks float time for activity H. That means, okay, I could start activity H in week 6, okay, because it just relies on activity C to be done. But as long as I've started it by week 12, it won't delay the project overall. Okay, so I've got 6 weeks float time for activity H. Make sure you calculate it like this, because this, you can see there's a difference of 6 here, but this will make sure you get the right one every time. If you've got 2 paths going into a box, it can sometimes mess up just looking at this. So make sure you remember latest finish time minus duration minus earliest start time. Okay, so what are the pros of critical path analysis? 1, you estimate the duration of a project. That's useful for customer service. 2, you can manage your capital, your labor, your financial resources. What do I mean by that? Okay, so it helps you identify where there are activities where there are float time. If activity H was particularly expensive, I might look to delay it, right? If I've, if I've got multiple projects on, I might have labor on other sites. I might have machinery, capital elsewhere. Okay, and I might need to juggle that and move it around, right? It might be critical for another project. Activity H can be delayed, so maybe I don't need to sort of move my stuff around. So it's great for a business trying to manage their resources. Okay, you're going to identify key activities that can't be delayed and those that can. There's cash flow benefits. If activity H is really expensive, I might want to delay that for as long as possible to improve my cash flow. And of course, you can update and adjust the critical path analysis as you go along. Let's say we have a problem early on. I can recalculate my critical path and update my client. Okay, difficulties. Right, first of all, it's complex to do. Second main one to look out for in a case study is who's done the critical path. Okay, often they'll just say it's one person who's done it. It might be the marketing manager, but there's loads of operational tasks in there. Does the marketing manager really understand operations or HR? So or is it someone who's really like pushing the project? So look out in the case study, who has made the critical path analysis? Have they got expertise in constructing the case study, in estimating the duration of these different activities? Okay, it doesn't take unforeseen circumstances into account, and it's only going to be as accurate as the data put into the planning. Okay, overall, you're going to want input from finance, marketing, operations, and people. Right, a complex project will involve recruitment, marketing, perhaps some operational stuff. Okay, the critical path is going to be best and most accurate if you